Hi everyone, and welcome to the first Women on Stage conference. Thank you for being here today again. I'm super excited to be here, and I'm thrilled to have all of you joining us again. My name is Moran Weber, and I'm the CEO and founder of Women on Stage. And for those of you who weren't with us yesterday, Women on Stage is a global community platform to showcase, book, and train women professional tech speakers for any event, conference, meetup, or webinar. The platform was launched in May 2020 and achieved overnight viral success, already making it one of the largest databases in the world for women professional tech speakers. Our mission statement is to amplify women's voices and to create a world where women make at least 50% of tech speakers, because we believe that if you can see it, you can be it. Apart from the platform, 3 months ago, we've also launched the Women on Stage Academy course, which is a full-blown course to train the next generation of women on stages. And today is the second day for our ending conference, where each of our 40 graduates will present their talks on 2 parallel tracks after they've been building and polishing their presentations throughout the course for the past 3 months, after getting tailored personal feedback from world-class speakers. Our speakers are working in senior positions at some of the best-known tech companies in the world. On top of that, we also have 4 keynote speakers opening each track. Yesterday we had 2, and there are 2 more today. Our speakers are going to present highly technical professional sessions covering data, machine learning, NLP, backend, cloud and big data, frontend, React, software languages, software architecture, and many more. Before we start, I'd like to thank again all of the people and the companies who made this course and this conference possible. Thanks to all of the awesome sponsors who actively choose to promote diversity as part of their mission. We truly couldn't have done this without you. Be sure to check our job board with lots of wonderful job opportunities. Thanks to Event Handler Productions for producing the event and for the team organizing the conference. Special thanks to Microsoft and the Baot community, which is the largest community in Israel for women in senior positions in R&D, for collaborating with us and to help us to turn our course into a dream come true. Special thanks to all of the course instructors, which are world-class speakers and true legends. And last but not least, to our brilliant and dedicated mentors who accompanied our students throughout the course. Alright, so one last thing before we start. You're welcome to join our Slack channel for chat and Q&A with our speakers. The sessions are pre-recorded, so the speakers are going to be available during their talks to answer all of your questions live. We'd love to hear your thoughts. Ready? Here we go!
We're here together today to talk about creating a path to female leadership. So I'm very excited to see you and to have this talk.
Me too. Let's figure out how we did that.
All right, so maybe we can do a quick intro. I'm Kate Ballinget. I'm the SVP of Sales and Business Development here at Nexar.
And I'm Reut Willig, and I'm an engineering team lead and execution manager at Nexar.
So I hail from Los Angeles originally. I've been here in Israel for about 2 years. I studied philosophy at UCLA, so I'm a big fan of first principles. I've been at Nexar for about 1.5 years, and prior to Nexar, I spent almost a decade at Google in the global business organization, and then the last 2 years I was at Waze doing business strategy, so came to Israel quite a bit. I have 2 toddlers at home, 2 dogs at home, a lot of balagan, as you would say. I'm loving Israel and loving my journey here at Nexar. All right, so I think the easiest way to understand Nexar is our founders. So they were both fellows at Yahoo working on image search. And as they're trying to figure out how to find, cats online, they thought it would be more interesting to do image search in the real world. So could they create enough imagery and compress, really fast neural networks on the edge to actually digitize the physical domain in real time, and then allow people to search, objects and roadside situations of interest and receive alerts. So it's a pretty ambitious vision. But I think the timing was right, more ubiquitous connectivity, more powerful chipsets and smartphones. And so Nexar really developed a pretty unique system for moving workloads between the edge and the cloud and bringing this really ambitious vision to life. And it's people like Reut who've actually helped pull it off. So I'll turn it over to you and explain how you actually did it.
So we are going to talk about the engineering of saving lives. I'm going to start with my previous job, where I was not serving humans, but routers. Then I'm going to move forward to talk about immediate alerts and the engineering of immediate alerts and what they require from us. We are then going to talk about the transition to a peace of mind and how immediate alerts are actually one side of it, but they are not exactly reaching the goal alone. And finally, I want to take you through some takeaways from that journey, from routers to humans to holistic peace of mind for the users. So I'm going to start with introducing myself as well. We're going to discuss my engineering career in just a few seconds, but before that, I am a researcher at heart. Actually, give me hard problems, I will be thrilled and happy. I might not solve them though, but I will be happy. I'm very emotional about data. I'm a fan of people, a servant of dogs. I am an amateur poet. How embarrassing. Can't believe I wrote this here, but it's here. And I'm also a really good binger and carb eater, aka BNC. So as a junior engineer, and this is frankly how I look like, I've been in this business for a long, long time. I was working at Cisco, and my users were actually routers and racks, and I had to come up with an answer to the question, what is this traffic that users are passing between different routers? So the question was basically, what quality of service do we give to that bulk of packets going through the internet, depending on what they are. And sometimes this is a very challenging work to do. But basically, you provide this answer to the router, and the router gets all kinds of decisions that help this traffic move forward in the fast lane or in the slower lane, depending on what that traffic was. Then the transition to Nexar was very overwhelming, because not only were my users not routers with zero interface or any way to know what you did. You just committed code and then the router took it and that's it. No, I'm kidding. We were very professional at Cisco. But here at Nexar, you actually constantly dealing with humans, and these humans are at a very critical time in their lives when they drive, and you should be there, protect them, and make sure that you give them everything they need during a ride and even after. and before. And what are those things? Basically, for our users, we have Nexa-ready dash cams that they place in their car. We have a smart application that accompanies that. So the users drive with our cameras, basically can retrieve any video they need from their ride. If something happens, you always have this evidence of whatever it was, and you can be very calm about that. Also, while you drive with Nexa, we give you real-time alerts, safety alerts, and other insights from the road ahead of you that help you ride better, safer, and calmer. Some of these alerts are going to be a bit more difficult to generate than the others. So let's start with the hard part of the immediate alerts. All the alerts that we support is divided into two, as I said. If this is a threat, like you can see in the video behind me, of a potential forward collision, then we need to alert the user as soon as possible that they are about to basically collide in the, in the vehicle in front of them. We have to be absolutely positive and sure that this is the case before we issue this alert. So we have to be very accurate, and also we cannot miss anything. So we have to be very, very inclusive in the alerts that we issue. So this is one type of alerts. The other sorts of alerts that we can issue are alerts that are not necessarily immediate. Like, for example, let's say that we detected a construction zone. Let's say you drove somewhere and then we got a footage from your camera. We analyzed it on the mobile device with our AI, and we figured out that what we're seeing right now is a construction zone ahead of us. Because we detected all those little cones and this construction zone walkers, we actually have models that can identify those things. You actually see it right now, so you have nothing to do with this information. We gather this information, we process it in the cloud. We take an aggregated approach here because we need to see more and more drivers meeting that construction zone, verifying that it's there and localizing it exactly in space before we can say there's a construction zone here, and then the next driver that will drive in this area will get this alert after it's been verified and localized. And of course ahead of time, so they can decide if they want to maybe bypass that blocked lane or intense construction area. Mm-hmm. So when you decide to work on immediate alerts, unlike construction zone or stuff that needs aggregation and can wait and they're not immediate risks, you only have a few milliseconds to reach a decision and to know that there is a threat ahead of you. You cannot rely on any other data contributors because you only have that driver driving right now, potentially almost hitting the driver next to them. So you have a single source of data, and I believe that some of you work with these kind of data streams, and you know that this means that this data has to be filtered, cleared of noises, which is something that usually having lots of data points give you, because you can balance it out, you can average this, but if you have a single contributor of data, you have to do a lot of work to make sure that your data is consistent, accurate, and noise-free as much as possible. So there's a lot of smoothing to do there. You also have to be super reliable with immediate alerts because usually you serve events that are very intense, real-time. You don't want to be just a false positive white noise for your users. You want them to rely on you and trust you once you say that something is happening. It's also important to understand that immediate alerts also usually involve a huge amount of parameters. So you have to take into account so many different variables that, again, you cannot average because you have this one user driving right now, so their camera can be placed in weird angles, or sometimes they can maybe have something in their setup that actually bothers you completely and creates really different environment setups, so you have to take that into account. And finally, immediate alerts usually require users' action. It's like not completely autonomous. I mean, we're not driving for the user, but we are having a call for action, and that is scary. That is really scary, indicating to anyone you should stop because you're about to hit something.
Wow, Ray, those are a lot of variables to consider. How do you prioritize? How do you pull something like that off?
Well, basically, you need to take all the data that you have. So our input data comprise of two main assets, which is the vision that we get from the camera and the signals that we process, either from the camera or from the phone or both of them, depending on the exact hardware. And basically what we do is we take all these parameters and signals and vision that we have, and we split the milliseconds, the very few milliseconds that we have to reach a decision, into detection segments and tracking segments. So in a detection segments, you have this fresh snapshot of reality. You reprocess everything and you get an accurate understanding of which cars are ahead of me and what are my current statistics of driving, GPS, velocity, acceleration, and blah, blah, blah. And then the tracking segments are where you actually just use those deltas to refine exactly these low-level parameters and get this understanding of whether I reached the point of where my alert should be triggered. There are different thresholds. When you meet them together, this is the time that you need to set the alert. And it's very important that throughout detection and tracking sessions, you constantly smooth. And you constantly cancel noises so that when you reach a threshold, you know that everything is aligned and you can now have an alert ready. So it's a lot of work, but the only way to make sure that you release such a product outside to users and you can sleep at night, at least most of them,
Yeah.
is having a strong simulation environment. And that is the key to everyone who wants to develop any real-time product. You have to make sure that you can simulate all of your alerts with all the possible variables that can happen. You can use different signals and videos and footage coming from different real-time use cases, but you should also augment your data. Data augmentation is basically taking real data and then tweak it slightly. So you can automatically create so many variants of your data, and your experience can be so much more inclusive to many situations that you did not come across. So taking this huge data set into action and making it constantly run, it's like CI for code. It's like continuous integration. Every time you evolve your code, every time you want to check a new approach, you know that you're covered. Because you collect your precision and recall. Precision is how many times you released an alert that was correct. And recall is out of the times you should have released this alert, how many times you actually did it. So it's really, really easy to stick to a high precision level when you don't always react. You only react when you're absolutely sure. But then you miss out a lot of interesting cases, a lot of cases where you could actually impact the user. So the trade-off here is constantly knowing how to balance the two.
Yeah.
You know? And this is what a simulation set does for you. It has to be annotated, meaning you have to have some way to evaluate when the alert actually should have been issued. So you could use manual annotators, you could use all kinds of self-learning models that actually train themselves to set that point in time where an alert should have been triggered by backtracking from a collision. No matter how you do it, you have to have that point in time where an alert should have been triggered on your data set. And that way you can evaluate any possible combination of logic that you want and make sure that you never break it. Before you release anything to a user, you actually know how your performance is like. But then we basically started thinking about the type of alerts that we are issuing to users. Like the event of almost colliding into another car is not always that frequent, and also when it happens, sometimes making the user react can be slightly overwhelming for some users. You want to get to a situation where you can prevent those cases from happening. And you can prevent those cases from happening when you have a calm driver that is focused, and you can avoid this altogether. They look at the road, they don't have to hard brake. You know, sometimes you can't avoid it. But we found that in many cases, providing an alert that is slightly less immediate, and maybe it's just about the dynamic features of the road that prepare us to the unknown, because we gather so much of unknown moments while we drive, right? What is the traffic light state? Someone is crossing the road. We get into a traffic jam and we weren't prepared for it. So many unknowns that it just keeps aggregating tension in us. And the less tense we are, the less likely it is that we get into risky situations. So that is what we wanted to tackle.
That makes a ton of sense. I mean, I've read about what a heavy cognitive task driving is. It's like you're performing something like 2,000 micro tasks every second that you drive. So finding any way to make it a little less taxing on the user seems really important. And it seems like Nexar is in a great position to do that because we have a lot of eyes on the road, right? A huge network of users that could be talking to each other about what lies on the road ahead.
Exactly. And basically reaching to that point where you can actually release such an alert to users. When I say such an alert, I mean insights from the road that happened a few minutes ago, that a few of our drivers saw. Is actually possible because we have this network of drivers driving together, so they can really educate each other on what's going on. Engineering of such events is really, really different because now you have many sources of data contributing to that insight. So we have a few drivers driving. Let's take the traffic light counter case study. This is an alert, by the way, that tells you as a driver when the traffic light is going to transition from red to green. And the way we do it is we basically learn offline how the periods and the schedule of the traffic lights work. And then in real time, what we need to do is to just activate that schedule based on drivers that drive next to that traffic light during the day. And we learn how the period shifts. And this is how we can issue the alert. So one driver, for example, driver A drives to an intersection. We figure out the shift according to the state of the traffic light that changes in real time. And then the driver that comes right after is already activated and they can get this alert and it will be accurate for them. So it's really like a game of activation. And this alert, unlike the previous alert that we talked about, this one is all about calming you down, telling you how much time you're going to wait in that red light. Sometimes it's so frustrating because you just don't know. You don't have to get a beep behind you to move, and no one gets upset around you because you just start going when you can. So it's like a holistic peace of mind kind of karma going between the drivers that are both Nexar drivers, but also the drivers around them.
That sounds like the kind of world that I want to drive in.
Exactly. Well, there is a lot more to this journey. We also developed an experience of live navigation with fresh frames and insights from the road ahead of you, accompanied with videos and frames to better prepare you to your drive in a way that you can really understand what's coming. I think that all of this journey that we've gone through kind of sits on two main principles that I gathered from this. The first one is how important it is to adapt your pipeline to the specific available data. When you have lots of data available, then you can play that game of aggregating and averaging and doing all those manipulations on the data that gives you actually the noise reduction and the smoothing that you need. And it's really different from relying on a single source and reacting to an immediate threat. And it requires different simulation sets. And basically, it requires you to ask yourself the questions of what data I can rely on, how do I buffer the false positives, what is my feedback loop? We can actually track if the alerts that we give make real difference in real life, and how users react to it. Do they heartbreak? Do they actually calm while they drive more than they used to? So that is a very important input to our loop. And you want to have a timeless effort. You want to be able for your walk to walk endlessly and only keep improving it, but never having to wake up at the middle of the night worrying about anything. And this is how we do it. And the other takeaway that I have from all of this is basically that the message matters. All the people that work here in Nexar are so empowered by the fact that they can actually contribute to making people's lives better and potentially even saving their lives. But it doesn't have to be such a dramatic goal. You just need to know that you did something good for a person, because a good experience or a happy user is also a happy driver, right? And I think that no matter what you do and no matter what is the product that you are developing, you have to make sure that the people that work on it understand the value that they bring to the lives of whoever it is that uses this. It's super important, and it makes us never compromise on the end result. And all those drivers that drive around, they actually gather huge amount of data that we can learn so much from and get so many insights and then let you sell it.
All right. So with that, we'll switch gears to how to sell it. I mean, the technology stack at Nexar is obviously really incredible, and the focus to date has been about building a great consumer experience and getting that network of drivers on the road. When I first started at Nexar about a year and a half ago, the question was, how do we take this technology and really kind of commercialize it and create a platform and more of an enterprise solution, so that we aren't just selling our own cameras, but we're working with third-party hardware partners who can also distribute our software, and that we're making the data and insights that come from this really rich asset that you described available to even more customers, people like smart cities or businesses who could also benefit from all these insights on the road. So when I started, the billion-dollar question was very much how do you stand up kind of another business around the stack? And for me, it was a question of, well, how do I build and empower a team that is capable of doing that? Because I certainly couldn't do it alone. So in the process, I went from a team of 1 to a team of 12 now. It's been such an exciting journey. And so I figured I'd close us out with just some lessons that I have learned here of how to build, manage, empower a team that can take a tech stack as rich, as diverse, as constantly evolving as what Nexar has to offer, and bring it out to the market successfully. So the first thing that I've learned as a kind of manager of this new team here at Nexar is really the number one job of a team manager is to empower the team. I always ask this question in every single weekly one-on-one that I do with everyone on my team, which is, do you have what you need to be successful? It's really easy in kind of status meetings to just jump right in of how things are going with this initiative, and but I've always found that it's really important to take a step back and make sure that your team has what it needs to be successful, and then you go into the specific updates of individual initiatives. The second learning about kind of building a high-performing team is to really facilitate kind of smaller cohorts of team members. So I encourage my team for every single opportunity, for every single project, to work in a small group. I think this is also really important in the era of this global pandemic, where we're all pretty distributed and fragmented, particularly my team that works across so many different time zones. It's important that every opportunity has 2 or 3 people working on it, so you can unlock those kind of collective problem-solving skills. A third kind of important lesson around building a high-performing team is to really encourage a culture of structured and strategic and data-driven decision-making. So, when we bring these products out to customers, people get really excited. It's easy to kind of get lost in so many different use cases. So I always encourage people on the team to kind of take a step back, build out a framework, take a really structured approach to kind of working with each individual opportunity. The kind of fourth principle, I think, around building and managing a successful team is to really create clarity on the mission, but enable creativity in the execution. At Nexar, things are constantly changing. We make a lot of pivots. We literally,
sorry about that.
literally build up like new lines of business around new products that are developed. So in order to kind of anchor people on a true north, I kind of always reinforce at every single team meeting, this is the ultimate mission of what we're trying to accomplish. How we get there is going to constantly evolve, and I empower people to be creative to get us there, but it's so important to reinforce like that ultimate kind of true north for the business and for the company. This is actually a great tip that I got from my boss, our CEO. I was getting really overwhelmed with the kind of 8,342 things that I needed to do one week. And it felt like every minute there was more being added to my plate. And he encouraged me to kind of take a step back and say, what is the one thing you need to get done this week? It's not about making a task list every single morning. Have that kind of one big thing that you need to get done and keep that top of mind throughout the week. And so I actually, in our team meetings, have everyone go around and say, what is the one thing they are working on that week? One, it kind of helps anchor everybody individually, but two, it helps us as a team figure out how can I help, my teammate now that I know the one most important thing to them that week. A sixth kind of tip for building a high-performing team is to really over-invest in the onboarding process. I think, at a startup, you can't take a week to, do like an offsite or a long seminar with people. They kind of get thrown right in, but just saying like, oh, they'll figure it out is kind of an all too familiar refrain in the startup world. And what I found is that, in order to get great work out of people really quickly, you have to spend a lot of time documenting processes and tools and kind of organizational structure. So taking the time, like sitting down and putting in the hours to do that documentation, and then meeting with your new hires every day for their first week, it's worth it. It pays off dividends, and you get great work out of people much faster. And then finally, I think that the most important thing that I've learned in building out this team and working here at Nexar too, because there are just so many people that I'm working with every single day, is that you need to be your best self. I have 12 reasons to be my best self every day, all of these 12 people on my team. And so you need to really figure out like what are those little things that you can do for yourself to make sure that you constantly have high levels of energy, you have enough endurance and stamina to make it through really long days, and you have enough passion. I mean, it can get a little overwhelming doing everything that we do. So you need that high energy level to constantly infuse passion and excitement in your team. So it's not just about hard work. It's about figuring out how do I create conditions to be my very best every single day. And when you do that and you build great high-performing teams, you put yourself in the best chance of success to take this really exciting technology and bring it to as many customers as possible. Thanks so much for having us. Take care. Bye-bye.
Hi everyone, and welcome to my talk, Extensionator, Rise of the Chromium. I'm super excited and very honored to be part of Women on Stage conference. My name is Karen Kenzie. I'm a senior software engineer at AppsFlyer. I enjoy photography, singing, painting, and more. And in my not so free time, I study psychology. Today, I'm going to talk about Chrome extension and how we can use our basic JavaScript knowledge in order to build our own. So what are we going to build today? I will give you a hint. Any guess? Well, no, we are not going to build a Terminator. We're just going to build an extension that increases the font size. Let's start. So in order to develop a Chrome extension, we need a Chromium-based browser. Then we need to go to the Manage Extension page. We can do it over here and see that our developer mode is set. The next step is, of course, to create a folder that will hold all our code for the extension. So let's create one. New folder. Let's call it my extension. Sorry about that. And let's open it with our favorite IDE, whether it's VS Code, WebStorm, or even Vim. The first file, which is mandatory for extension, is the manifest file. So we will start with it. The manifest file is a JSON file that basically holds all the relevant information for our extension, like its name, its description, its version, etc. Let's create this file. There are a few mandatory fields we need to provide. Those are name, which is the name of the extension, my super font extension. We need to provide a version. The version can be any number. Just keep in mind that whenever you update your extension in the store, you need to increase this number as well. Let's start with 0.1, and we also need to provide a manifest version. The currently supported version is version 2, but they are soon going to release manifest version 3, which will enhance security, privacy, and performance. So those are the mandatory fields we need for an extension. Let's load our extension. We will go over here, click on Load and Pack, and select the folder of our extension. Let's see. Where is our extension? There it is, my super font extension. If we want to see the details, we will click on this and we can see the version. Currently, there is no description and no special icon. Let's go back to our IDE and add a description. Sorry. Increases the font size. When we make changes to our code, we need to go back and refresh our extension. Now we can see that the description was updated and we can see it over here. Currently, our extension doesn't do anything. So let's go back and write the code. When we write an extension, all the script that runs in the background are called background script, and they are in charge of the logic and the interaction with the Chrome API. So let's add background script. It's an object which in the manifest, we need to specify the background, which is an object that specifies all the scripts that we need to run in the background. Let's call the file the same, background.js, and copy paste it to create the script itself. Okay, so for the background script, we want to add item to the right-click menu. For that, we will use the Chrome context menus API and use the function create. We need to give the item a title, which is super size. The font, for example, we need to give it an on-click. Sorry for that. My zoom hid my mouse. So we need to give an on-click, not on link, on-click function. Let's call it increase ink font. And let's go over and create this function. The function will receive two objects, info and tab. For now, let's just console log the information. Other than that, we need also to provide the context in which we want to add the item to the right-click menu. It can be either when we click on an image or a page or a link. Let's select a page. It can also be a list. And that's about it for now. Let's go over here, refresh our extension, and we can see that we have some errors. Let's see what the errors are. We get an error that we cannot read property create of an undefined. This is because we are trying to access the context menus and we don't have permission for it yet. In order to provide the extension with permission, we need to define the permission in the manifest. So let's go back to the manifest and add the field permissions, which is an array of all the relevant permission that we need for our extension. Now let's go over here, clear all, go back and refresh, and no errors to be found. Let's open a web page such as Wikipedia, the Terminator page, and see if the item was added to our right-click menu. I see I have here, 2 items added. I think it is because I played a bit with the extension before. Let's rename the title of the item, supersize. Let's name it like supersize my font instead, so we can differentiate between the 2 items. Let's go over here. And supersize my font is the latest Chrome extension we just created. So when we click on it, nothing really happens right here because we didn't add the code that increases the size. But if we will go to the extension and click on the background page, we can see here the console log we just printed with all the information inside the info and the tab. We can see information such as the page URL and more. So let's go back and add the script that changes the font size. So beside the background script, there are other scripts, which are the content script. Those are the scripts that are responsible for the interaction with the web page itself. We can either declare it in the manifest and specify the file itself and the pages we want to the script to run on, or we can inject the content script programmatically in the background, for example. So let's do this thing. Let's inject the script over here. We will use the Chrome tabs API and call execute script. We will run the following code. So we want to change the font size, therefore we need to access the document body style and font size. Let's say we want to increase the font size to 32 pixels, for example. Sorry, I have an additional typo. Let's go over here, refresh the extension, and let's see if it works. Click over here, nothing happens. Why? Let's see if we have any errors. Well, we do. We cannot access content of a page. Why? Because we haven't added the relevant permission. So let's get back to the manifest and request the permission also to the active tab. This will allow us to access the web page itself and change the font. Let's go back, refresh the errors. Let's clear the errors, go back, refresh it, no errors, and let's see if our extension works. Click on it, and ta-da! Our extension works. It changes the font size to a larger font size. Last but not least, let's change the icon of our extension. We can do that by going back to the manifest and specifying the icons we want to use. We can set different types of icons for different sizes. And if we provide only just one default size, the Chrome extension will take this image and shrink it so it will fit to different sizes, because the icons will appear also in the web store and also in our case in the right click next to the right click menu item. So I've pre-downloaded images before. Let me just copy them. Extensionator. Sorry. Let me just copy the image. Let's say we want to use the plus icon. Let's go back to our project and add it here. And let's specify it was added over here. And let's edit plus PNG. And as usual, we need to go back and refresh. And we can see that our icons over here as change. And also if we go back to the page and right click, we can see that the icon was also changed here, and it will help us also to differentiate between those two extensions. So that's about it. And if you want to check out the code, you can scan this QR and see it on my GitHub page. I want to thank you very much for joining me in this talk, and I hope that I inspired you to write your own Chrome extension. Oh, and by the way, if you choose to upload your extension to the web store, you need to create an account, zip your folder, and upload it to get a review. And if your code passes the review, it will be uploaded to the store. So thank you very much. You can reach me either via LinkedIn or Twitter, and have a wonderful day.
So hi everyone, I'm so glad you're here. I'm going to talk to you today about Chrome extensions. Hi, I'm Shir. I'm a senior full stack developer and I've been doing mainly full stack for the past 8 years. I didn't thought I'd become a programmer. I mean, as a kid, I wanted to be a ballet dancer. I actually started to program before I knew what it was. You see, I was 12 and I wanted to have a website about fairies, and so I looked up what was needed to create one. I ended up learning the basics of HTML, JavaScript, and CSS, but I didn't think I was programming. I thought I was just creating a website. Long story short, I ended up majoring in computer science at high school and thinking that it's interesting, but it's also only for people who want to build computer games, which I had no interest in. It was only in the army that I realized you can actually build and create so many meaningful softwares. And it was also only then that I realized I actually programmed when I was 12. For me, the best part about software development is the creativity that comes with it. It makes me so sad to hear people describing it as gray and boring, because I think it's pretty much the opposite of that. So for me, creativity really is what makes software development the wonderful thing that it is. Now let's dive into the lecture. We all use extensions, right? Whether you're using ad blocker or maybe you're using Grammarly, you have some installed. We kind of take them for granted these days, as we're so used to having them. But it wasn't so long ago that they didn't exist. So let's have a quick recap. The first extensions were supported by IE in 1999, and little by little, 10 years later, all existing browsers supported them. Chrome extensions are giving the user the opportunity to extend the already existing functionality of the browser. With time, extensions have gained the ability to do more and more in the browser, which in turn made them grow in popularity. Side note is that nowadays, most browsers support a very similar API for extensions as Chrome does, meaning if you learn the API of Chrome, you pretty much know how to do it for other browsers as well. So what's so cool about that? Well, it brings up a whole new world of possibilities. We have the ability to modify or enrich the experience of another software. An extension can do almost anything on the existing page, that is, once you allow it. And for a product, that's some great power, the ability to add on to the actual structure that the user requests us to. We have more information about the current state of the user. While on regular full stack, we can only ask the user for information or maybe get it when he integrates with some other services. When we develop extensions, by living in the browser, the user immediately allows us to get information about the browser. And so we are able to create something that can be much more precise. And you can actually base a full platform on these. Though most extensions use this just to interact with a single page, you can actually build a full-on application using the APIs that are provided by Chrome. I've written full stack code for more than 8 years now, so I thought extensions development would be very similar to that. I mean, it's still web dev, isn't it? So nope, it's still JavaScript, but it is different. The basic of the difference comes from the fact that you're writing code that runs in other people's websites. That's a game changer. Moreover, since we're actually living in another software, debugging and deploying is also very different. Okay, so what are extensions really made of? Let's talk infrastructure. Each extension is usually made up of these 4 basic components. First off, we have the manifest.json, which is the config. This is the place that holds references to your extensions icons, to other required scripts, and to the required privileges that your extension is going to ask for. Then you have the UI components. You can have many or you can have none. And the basic one is called the pop-up, which is that little view that is opened once you click on an extension. Then we come to the 2 more interesting components, the background and the content scripts. Since extensions are all about reacting to certain browser events, background scripts are the scripts that will actually listen to these events. It handles all the events from the browser, not only for the specific page. Let's take an example. There's an extension called Dark Reader, and if you're not familiar with it, it's just a great one. It turns your whole page black. So let's say you are the Dark Reader extension, and you've darkified the whole page. Great. Then your user switches to a new tab. So you probably want to be notified about that to be able to darken that page. This is where the background script comes to play. The background script is where you will register that events handler. Now let's take a closer look. Here you can see the Women on Stage website. And you see that I got the Dark Reader extension open up. By the way, this is the pop-up that I talked to you about before. So again, here the Dark Reader is toggled off. And this is how the page looks like once I turned on the extension. As you can see, it's dark. Now the user opens a new tab, and you're going to see what will happen in the developer tools. I put on a breakpoint beforehand. Bam! As you can see, the background script stopped on a breakpoint. This breakpoint is inside of a listener that listened to the tab changed event. So this way, Dark Reader knows that it needs to darken the new tab that the user opened. I want to emphasize this once more. This doesn't happen on the page. It happens in the browser. And because we live in the browser, we're able to catch this. Moving along to content scripts. Content scripts are the JavaScript that we actually inject into the web pages. That way, we can do various things, like get data from the page, add or change something in the UI, etc. In the Dark Reader example, this is the part that actually changes the CSS of the page, so it turns dark. This is all done through content scripts, using a concept called isolated worlds. Isolated worlds, in a nutshell, basically means that the extension scripts and the web page scripts don't conflict with each other, and they never will. The last piece of architecture that I wanted to talk to you about today is messaging. Since content scripts run in the context of a web page and not the extension, they often need some way to communicate with the rest of the extension. The solution for this is called messaging. Basically, there are two Chrome APIs that allow us to message from content scripts to extension scripts and vice versa. One is called the Chrome Runtime API and the other is the Chrome Tabs API. These APIs are based on the event handling mechanism that exists in JavaScript. And so we are able to trigger a message from one component and assign an event handler on the other side that will catch it. In the example that is on the screen, you can see how simple it is to use those APIs. Lastly, there are some challenges. The first one that I want to talk to you about is conflicting with your host's user experience. As an extension, you want to make sure that whatever you're putting on a page that is not yours is not interfering with the existing user experience that is already there. It's a major one because we don't know what a user experience is, so we have to be pretty gentle. Second challenge is that we want to stay compatible with the different markups. Again, since we are an extension and we run on different websites, there are so many ways today that people write their own markup, or it might be just the type of the programmer, it might be a framework that is generating that markup. Whatever it be, we want our extension to behave the same on different markups. And lastly, I want to mention that deploying is actually not in your hands. When we write full stack, we are used to be able to just choose a method of deploying and do the whole thing ourselves. It's not the case when you're writing an extension, because deploying an extension is actually uploading it to the store. And the process of uploading an extension to the Google Store means that you have to go through an approval cycle. This might take an hour, it might take a day, and it might take a week. So it's just important to mention that you have to take this into consideration when you want to deploy. So this was it. Today we talked about Chrome extensions. I want to sum it up and say that we talked a bit about the history behind them. We talked about the different components that are necessary for it. And we also mentioned how they work. We examined some of the opportunities that arrive with it, as well as the challenges. I hope it was interesting and that you'll give extensions development a try sometime soon. Thank you so much for your attention. You can find me out on Twitter at Maciszewski. That is, if you can spell it. Thank you very, very much.
Hi everyone, my name is Shiv. I'm a full stack software engineer at Amenity Analytics, where I write UI across several applications using React. I mostly write functional components with React hooks, but I also maintain legacy code written with class components. I was told to put my Twitter handle on the deck, but the truth is I don't tweet much, but here you have it anyways. So today we're going to do a deep dive into useEffects dependencies. We all know useEffect, right? It's one of the most common React hooks. We are using useEffect to run side effects in functional components. The effect runs if something that the effect depends on has changed. We specify what effect we want to run, and we specify a dependencies array. Every time any of the dependencies changes, the effect will run. Also, the effect always runs after the first time the components render. Now, if we leave the dependencies array empty, the effect will only run after the first time the component renders, and that's it. But why is that? Between one render to the next, React checks if anything in the dependencies array has changed. And if the array is empty, nothing inside it can change. So that's why the effect will not run again after the first render if the dependencies array is empty. Sounds simple, right? Actually, it's not always so clear what goes into the dependencies array and why. Let's see an example. I have created this little super simple social networking app. It really cares about your privacy. So all it shows is just your username. And I've got a bunch of users. The app is really made of just two small components, the app component and a user card component. This is the app component. It takes an array of user IDs and renders a user card for each user ID. And this is the user card component. It receives a user ID as a prop. Then we fetch the user's details from the backend with that user ID. And then we can display the username in the card. And I also want to log each time the component renders, just to keep track of things. Now, we want to fetch the user just once. So we call the function fetchUser inside a useEffect, and we give it an empty array of dependencies, which, as we know, will cause the effect to run only after the first render. And that's it. Which is what we want, right? We only want to fetch the user once. So why are we getting this lint warning? This fuzzy yellow line under the empty dependencies array? The linter is telling us that the fetchUser function should be one of the dependencies for the useEffect. Now that's annoying because this function isn't changing. It always has the same logic. Get the user's details from the server. It's the same logic every time. So how can it change? To understand this, it helps to look at how the component renders over time. Let's take a look at 2 consecutive renders. Now, let's say for the first render, the component renders with user ID equal 1. And then for the next render, the user ID somehow changes to this ugly string. In React, the props stay constant during each render. So for the first render, React will create the first instance of the user card component with the fetchUser function using this URL in it. So it's going to be a constant URL. And then for the second render, React will create another instance of the user card component with the updated user ID and with a different fetchUser function with a different URL. Each time the component renders, React takes the user ID from the props and recreates the fetchUser function. And therefore, this function does change from one render to another. And that's why the linter is telling us to put the fetchUser function as a dependency for the use effect. Fine. So now we put the fetchUser function as a dependency in our use effect. But the linter is still not happy. Now the whole fetchUser function is marked as problematic. Let's see what the linter has to say. Remember, we said React recreates the fetchUser function for every render. So since the function changes every render, and it is in the dependencies array, our effect will also run every render, which is totally not what we want. Not only we will go fetch the user from the server every render, we also call setUser inside the fetchUser function to set the user using the useState hook, which in turn triggers the component to render again, which makes the effect run again, which sets the user again, which triggers another render, which makes the effect run again. And now we are in an infinite loop of renders. Now, while your app keeps re-rendering, it might not be interactive, and your users will not understand why, because it looks like everything already loaded. Also, fetching data from the server usually costs money. And if you're using a third-party API, you might also surpass your quota and lose access to the API. I actually lost an API key this way once. Luckily, it was a free API. Okay, so let's move the fetchUser function inside the useEffect callback according to the linter suggestion. Now, the benefit of moving the fetchUser function into the useEffect is that now it's very clear that the effect depends on the user ID prop. And indeed, we see this another linter warning telling us to include the user ID in the dependencies array, which makes a whole lot of sense now, right? So now the useEffect has exactly the dependencies that it needs, which is the user ID prop. So what did we learn? Functions that use props do change. Their code belongs inside the useEffect. And this way, it is much more clear what really needs to go in the dependencies array. Thank you so much. That's it for me. And feel free to reach out if you have any questions.
Hi everyone, I'm Lee, and today I'm going to make a server-side rendering introduction. Before I start diving into that subject, I want to introduce myself. 7 years ago, I started as a QA at a startup that is called Minute Media, which is also where I am currently working at. 1 year later, I left to Beersheba to learn computer science. While being a student, I had my very first job as a front-end developer. After graduation, I came back to Minute Media, and this time as a front-end developer, and today I am a team leader. Since I came back to Minute Media as a developer, I had multiple chances to talk with other people from the same professional field. And I was trying to explain what I'm doing in my current job. And I was saying that I am a developer and I'm using React and Redux, and we have a service that renders the HTML, which is basically server-side rendering method. And more than once I got questions about that subject. What is this exactly server-side rendering method? And how can we render HTML in the server? This is why I decided today to talk about that and explain what server-side rendering is and what are the great benefits that come with it. I want to start with the word rendering. We all know that when a user enters a website page, what he sees is represented by an HTML markup. And the question is, where was this HTML markup created? In the client or in the server? If it is created in the client, it means that the browser had to run some JavaScript code in order to generate the full HTML markup. And this is the client-side rendering method. In client-side rendering method, the flow is that the user enters the website page, a request is sent to the server response includes index.html, with JavaScript code that runs in the browser and then generates the full HTML for the client. This method might be more familiar because many libraries and frameworks in JavaScript tend to use that method in their documentations. For example, React used this method in its documentation for Create React App, which is a very popular and comfortable way to start building React applications from scratch. Here's an example for an application in React using client-side rendering method. Let's say that what we see in the right side, the index.html, is the response from the server. We can see that the markup is almost empty. It includes one div with no content in it. In the left side is the code that must be run in the browser in order to generate the HTML markup. So the browser generates the HTML markup with the header, content, and footer, and then injects this markup into the div with the ID root that we got from the response from the server. And this is how we generate the markup in the client side. So the content here depends on the code. We might start getting a sense of why client-side rendering can damage our user experience. Before we had the ability to generate full HTML markup by JavaScript in the browser, like the example that we just saw with React or Angular or Vue.js, servers had to return the full HTML markup in their response to the client. So server-side rendering is not a new method. This method has always been there even before we had the option to use client-side rendering. Server rendered the HTML by returning a static HTML file or by processing the HTML markup via some JavaScript, some server-side languages like Java, Python, or PHP. Today we have Node.js, which is a great backend environment to render HTML in the server side. It has the amazing benefit, which is using JavaScript in the server. And it means that we have an isomorphic code that can be run both in client and in server sides. We can definitely take advantage of it and use almost the exact same code that we use in order to generate the HTML in the client side, but this time in the server side. Back to the example that we saw before, let's try to turn it into server-side rendering. So before the server sends back the response, it assembles the HTML markup in the server. We can see here the code that runs in the server in order to generate the markup. It generates the markup with the header and the content and the footer. And the code is not that different than what we saw before. It is JavaScript. It is React, and the only difference is the usage of the library React DOM server, which is a library of React that enables us to create React applications in the server. So when we generate the markup in the server side, we can save it in a variable. For example, here is the variable called HTML. And then we can inject it into the response that we send back to the client in the index.html. And this is how the client gets the full HTML markup in the response from the server. And this is server-side rendering. Because HTML markup is rendered on the website server, both search engine bots and humans get a faster page experience. For humans, it means better UX. In client-side rendering, the browser has to download the JavaScript file and execute the JavaScript code before it could display the page content. In the meanwhile, the human has to deal with a blank page, which is a bad indicator for user experience. Server-side rendering solves it by serving the full HTML immediately to the client. For agent bots, it means better SEO. When Google and other search engines bots try to access a website page, Instead of having to wait for JavaScript to be executed in order for the page to become available, they'll get the fully rendered page right from the server. This eliminates the risk of partial indexing that can happen with client-side rendering. In addition to SEO and UX, server-side rendering gets us a better performance. Not every device is the same in terms of hardware capabilities. A page rendering on the client side relies on this device hardware while rendering. A low hardware may fail to render the entire page in optimal time. Since in server-side rendering, HTML is rendered server-side, the devices have little relevance to the load time of your page. Since most servers are capable enough, the load time of all devices visiting the website is consistent. Here we get 3 great benefits using server-side rendering: UX, SEO, and performance, which they all together lead to better achievements and more revenue for our website. I explain what server-side rendering is and what are the great benefits that come with it. However, there is still one issue that I want to talk about. What happens if our website page is too large and requires a lot of data from network requests, like we see here in this example? This example is the same example as we saw before, only with the recommendations section. What if this recommendations section requires many requests to different services that we didn't have to communicate up until now? What if it takes time and we don't want to wait too long before we send back the response to the client? Maybe it is better if this recommendation section could be excluded from the rendering process in the server side. We might want to consider a third approach, which is hybrid rendering. Hybrid rendering is rendering a page on both client and server sides, rendering the most important content in the server and the less important in the client. How can we render a specific part of our page in the client side? Well, we can do it in multiple ways. We can add to our bundle JavaScript code and we know that runs in the client some JavaScript that only renders the HTML by an action. For example, on click event or on scroll event, or maybe using intersection observer that can include some JavaScript code that generates the HTML when this HTML enters the user viewport. In React, we have a special hook that is called useEffect. By using this hook, you tell React that your component needs to do something after it renders. React will remember this function that you passed and call it later after performing the DOM updates. The important thing is that useEffect does not work on the server side, and we can use it in order to get the hybrid rendering. Here's the example for the code of the recommendation sections component. We see here that the recommendation markup is only rendered when it includes articles. And the initial values of this component is an empty array. So the recommendation will not render the markup up until it will have the articles. And we can also see that we are using the hook of React, which is useEffect, and the functions that we are passing to it is including the fetch recommendations function, which is a network request. And only when we get the response from this network request, we update the articles of the recommendation sections, and only then the component re-renders and generates the markup of this section. Because of the way that useEffect works, we can be sure that the functions that we pass into the useEffect will not be executed in the server side. So basically, the recommendation component will not generate the markup in the server side. So when we return from the server the response to the client, the index HTML, it will include the full HTML markup, however, without the recommendation section. So we excluded the recommendation component from the rendering process in the server side, and it will only take place in the client side because of the way that we wrote JavaScript code for that component. And this is how we get the hybrid approach, the hybrid rendering. With the hybrid method, we get even better UX and performance because the page loads faster and the user gets to see the most important content almost immediately. So my recommendation is to combine those two methods, combine them and have better scores for performance, SEO, and UX. Thank you.
Hi, hello everyone. Thank you for joining me today in the Women on Stage conference. In my talk, we will learn about the story of Reason Ahmed, or maybe the story of the future of web. Well, we don't know for sure, at least I don't know, but I will share from my experience, and in about 15 minutes, we will know a bit more. So, hi, I'm Sarah Hillel. I'm a software engineer and digital nomad. I work at Walnut, where we make great demos for great companies. Before that, I worked as a freelancer for 5 years. So for most of my career, I work with early stage startups, in which you have to make so many decisions with an enormous impact. It starts from the very beginning with questions such as, how do you even decide on the stack? It's hard. In recent years, it has become even harder. You have so many options to choose from. But how do we know? What will work for us? What will make our code maintainable? What will make our work fun and productive? I've noticed that modern web technologies are evolving towards four simultaneous trends. The first one is easy. There is no paradigm shift here. For the browser, JavaScript is a standard. Always bet on JavaScript seems to be accurate for the near future, whether you like it or not. The second trend, static typing. More than ever before, developers want statically typed systems. One tool that has kept shining over the years is React. For those who don't know, React is a declarative, efficient, and flexible JavaScript library for building user interfaces. And it's popular, very popular. When I try to explain its popularity, I think about how it makes me code. And for me, React is like a pit of success where it's easy to do the right things and annoying, but not impossible to do the wrong things. Let's try and see it in code. React is component-based. This is component. You build encapsulated components that manage their own state, then compose them to make complex UIs. Components can receive inputs, props. Props are immutable. You can read them, but you cannot change them. Granting immutability prevents side effects, which makes your code more predictable, simpler to understand, and easier to debug. Composing components give you a hierarchy, which facilitates unidirectional data flow. Composition, immutability, unidirectional data flows are all functional techniques that make you reason about your code. Which brings us to our third trend, functional programming. We've reached the last one, a concept which attracts many developers and companies. Learn once, write anywhere. Web, mobile, desktop. So what have we got so far? We've got JavaScript with patches. A patch for static typing, a patch for immutability, a patch for functional programming. You find yourself bike shedding with configuration and endlessly adding and learning libraries. Is there any other way to do this? Why not just focusing on code? Well, meet ReasonML. We'll jump right into the code. This looks familiar, right? It is exactly the same React code we've just seen, but now it's written in ReasonML. You might ask, where are all the types? What questions? We don't see them here. And that's the beauty of ReasonML. It has a sophisticated type inference system. What is ReasonML? ReasonML, or Reason, was created by the same guy who created React at Facebook. Is it a new language? No, ReasonML is not a new language. It's a new syntax for the established OCaml language, but is meant to be familiar to JavaScript developers. So basically, ReasonML is OCaml with JavaScript syntax, and both Reason and OCaml can be compiled to JavaScript with Backend, a super fast compiler. You may be wondering what an L stands for. Clearly not machine learning, right? Maybe for OCaml? Close enough. ML is an abbreviation for meta language, which is a functional programming language. It might be known for you from your academic studies, and it's best known for its use of the Inley-Milner type system, which automatically assigns the types of most expressions without requiring explicit type annotation. And we've just seen it in the code with type inference. Today, there are several languages in the ML family. OCaml is just one of them. So let's talk a bit about OCaml. OCaml is a battle-tested functional programming language with more than 20 years of type theory. OCaml defaults to immutable and functional code, but allows escape hatches into imperative code when you need it. As we said, ReasonML and OCaml has the exact same AST. They only differ by syntax, and both can be compiled to JavaScript directly in the browser with Backend. Go to native code or bytecode. Alternatively, you can use the new REST script, which is rebranded ReasonML with Backend altogether. Let's have a look in some of the language gems that might be unfamiliar for JavaScript developers. One small but odd thing you might see here is the tilde. This is for label arguments or named arguments. But the main feature in this slide is variant. Variant is data structure that enables you to choose from a variety of options. So in our case, topic can be either frontend or backend or data. All are called variant constructors. The bar separates between them. Variant constructors can hold extra data. For example, here, the frontend topic can store the language name, a string. In our case, it might be ReasonML. When you combine pattern matching with variants, you get a powerful combinations that lets you execute some code based on the shape of the data. So here, we avoided messy if-elses, and we get a clean results based on the values. Now, what happens if we miss a value? When we fail to handle every scenario, like here. So we have a compile exhaustiveness check, which will save us from this bug. And it's pretty expressive. You can understand very easily that we miss the data constructor here. We are close to end, and I'm sure you have more questions than you had before the beginning of this talk. Things like, is it ready for production? Do you recommend it? Is it hard to learn? I want to tell you about two real-world use cases, and I hope it will address some of the questions, or at least will make you curious enough to explore more on your own. The first use case is of the Messenger app by Facebook. They released some statistic in 2017-18 after factoring 50% of the Messenger app to ReasonML. They reviewed parameters regarding quality of code and developer experience, and the numbers are mind-blowing. For example, instead of getting bugs reports on a daily basis, we're now getting 10 bugs, not per week, not per month, per year. They also significantly reduced the factoring time and build time. So this is how ReasonML worked for a big company. Our next use case is ours at Walnut. I have no references since we start with Reason from the beginning, but I can say we have a great onboarding process where anyone who joins us without any prior knowledge of ReasonML or the codebase is able to push to production in just a few days and to make wider factoring in the first few weeks. The trust and confidence we have in the code is part of this success. That's it. In case you're curious and want to explore more, here you can find some links that can be useful. You can play with Reason on the browser. You can join the great community on Discord. You can read about it, you can start a new project, or even you can add Reason in your existing JavaScript codebase. Feel free to contact me. You can find me at Sarah Hillel on most platforms. I hope you enjoy it. Thank you very much.
Hi everyone, thank you for joining me. In this session, we'll have an intro to event-driven development, or in short, we can call it EDD. So hi, my name is Tal, and I've been a full-stack developer for the past 3 years. I love learning and I love creating things from scratch, and these are two of the reasons why I became a software developer. Who here has used a sign-up or a login to an app? Did any of you fill a form and expected to see a success or a failure message after submission? Any in-app notifications? Whether you're a software developer or just an application user, you've encountered event-driven development in your daily routine. As the name suggests, with event-driven programming, application software is designed to react. In terms of programming, events are actions that a user performs, such as mouse click or keystroke. It can also be system generated, like program loading or messages between sensors. As soon as the user performs an action, the application detects it and deals with it using event handling procedure. These days, where every one of us uses mobile or web apps as coherent part of our life, we expect them to be fast and responsive. Driven programming serves the user with the quickest and most accurate responses, which typically translate into better user experience for any given app or program. EDD must not be considered as programming language or technology. It is an approach that's implemented during the product development. It can be written in any language and is supported by almost all object-oriented and visual languages. I work at a company where we do projects, so I get to work with different frameworks pretty often. In the current project I'm working on, we're using a relatively new framework, and we had a problem passing information between components which aren't rendered under the same tree in the DOM. After exploring a bit, we decided to implement a PubSub mechanism. PubSub is basically an architecture where there are publishers of messages and subscribers that use those messages. Once a publisher fires a message, the subscriber will catch it, process it, and handle the information in the way it needs it. It's a specific implementation of EDD. When I needed to learn this mechanism, I deep dive into this topic, and I understood that I've been using it without even knowing it. Every time I added an event listener to an HTML element, or even when I used Redux, the dispatchers. The events are dealt with by a central event queue, usually called a dispatcher or a scheduler, that runs continuously in the background and waits for an event to occur. When an event does occur, the scheduler must determine the type of the event and call the appropriate event handler to deal with it. The information passed to the event handler by the scheduler will vary, but will include sufficient information to allow it to take any action necessary. So we've mentioned dispatcher and event handler, but what are they? In an event-driven system, a number of events can occur in a relatively short time. The scheduler and the event handler may not be able to handle all of the events immediately as they occur. The obvious solution is to place unhandled events into an event queue until such time as they can be dealt with. Events are added to the end of the queue as they arrive and are dealt with by the scheduler once they reach the top of the queue. Event handlers can be seen as small blocks of procedural code that deal with a very specific occurrence. They will usually produce a visual response to inform or direct the user and will often change the system state. The state of the system encompasses both the data used by the system, like the value stored in a database field, and the state that the user interface itself. For example, which on-screen object is currently focused, or what is the background color of a text box. Within an event-driven programming environment, standard events are usually identified using the ID of the object affected by the event, meaning the name of a button or an input field in a form, and the event ID, such as left click, double click, etc. The information passed to the event handler may include additional information, such as the X and Y coordinates of the mouse pointer at the time that the event occurred. Each event could be handled by one or more handlers. They will get the same information from the event, but will use it and process it differently. Such as the cupcakes you see in this picture. They all started with the same ingredients, but were processed differently, and therefore we see different outcomes. Now we're going to see two short code examples of how EDD is implemented. Here we can see a very simple HTML. We just have a button with an ID of subscribe. Here we're creating a new JavaScript custom event called new message. It holds the detail of a message that says, thank you for subscribing. We're adding an event listener to the button that every time it's clicked will dispatch the event we just created. We have another component in our app. We're adding an event listener to it to listen to the new message event we created and handle it with the new message handler. In the new message handler, we see that we're taking the message from the event detail and write it in the inner HTML of an element that has an ID of greeting. Now we're going to see an example of Node.js. For those of you who are not familiar, Node.js is an open source cross-platform backend JavaScript runtime environment that executes JavaScript code outside a web browser. Node.js lets developers run scripts on the server side to produce dynamic web page content before the page is sent to the user's web browser. Here we create a server listening on port 8081 localhost. On the server object, we call the on method for registering two listeners functions. The listening event fires as soon as the server starts, while the connection event fires when a client connects to the local host. Let's review the disadvantages of it. Since events are asynchronous, there can be no anticipation of a specific order of occurrence or assured delivery of anything. Duplicates may occur in differing conditioning that may each require a contextual response. Development can be somewhat complicated due to the asynchronous nature of this pattern, as well as contract creation and the need for more advanced error handling conditions within the code for unresponsive events handler or failed brokers. Perhaps the most confounding challenge in using EDD is the difficulty in providing root cause analysis for any given failure. As the amount of event producers and event consumers increase, it becomes more and more difficult to trace back activities occurring within and between them. While individual unit testing is not overly difficult, it does require some sort of specialized testing client or testing tool to generate events. Also, when not dealt with correctly, it could be hard to identify the specific event that causes a bug or the matching event handler when a few are triggered by the same event. EDD may have a few flaws, but it definitely has a lot of important advantages. EDD system provides an extreme level of encapsulation and separation between components. The great distribution of this paradigm exists because an event can be almost anything and exist almost everywhere. The architecture is extremely loosely coupled because the event itself doesn't know about the consequences of its cause. Since event processors components are single purpose and completely decoupled from other event processors, changes are generally isolated into one or a few components and can be made quickly without impacting other components. One of the most important values of its high performance it helps achieving through its asynchronous capabilities. The ability to perform decoupled, parallel, asynchronous operation outweighed the cost of queuing and dequeuing events. When we look at the future of EDD, like Node, I've mentioned before, we're seeing increase in the use of serverless applications, which are using events as their core. More frameworks and architecture based on EDD are created and existing ones keep on being very popular. It's not hard to see that EDD will only get an even more integral part of software development as we keep the user as a center part of our application. Thank you for listening. Please feel free to reach out and ask any questions that you might have.
Hi, welcome to Guidelines for Developing UI Components. My name is Chava and I'm a full-stack software engineer and tech lead at Google. Today I'm going to talk about common guidelines and best practices which I find useful for designing the component hierarchy of a web application. In the past 2 years I've been implementing and maintaining a complex UI model. The guidelines and best practices that I will share here in this talk are the lessons that I've learned from my own personal experience. I'm also going to talk about Ninja Warrior, which is my favorite TV show these days. I'm sure you all know it. Each episode has a series of obstacles, and candidates that complete the obstacles at the best time move to the next level of the competition. I've built an application that stores the result of every candidate in each obstacle in the series of obstacles of a specific episode. And throughout this talk, I will analyze the component hierarchy of this application. So what are UI components? UI components are the building blocks of a web application. The basic components are the inputs, the drop-downs, the buttons, and so on. They are usually part of a design system that is shared across the organization. In this slide, you can see the basic components of Angular material. This is the application I told you about. You can see here the selection of candidates, and for each selected candidate, it is possible to view and update the results in each and every obstacle of the specific episode. You can see highlighted the basic components that are used in this application. Custom components are composition of basic components. You can see highlighted here a custom component that is responsible for presenting and updating the results in a single obstacle. You can see that this custom component is indeed a composition of basic components. Custom components can also be a composition of other custom components as highlighted here. Angular and React are both UI frameworks that are component-based, meaning that everything is a component. However, it is up to the software engineer to decide what is the hierarchy of components and how the entire application is separated into multiple components. And this is what we are going to discuss today. So let's start with the guidelines. I'm going to talk today about those 5 guidelines. Some of them are clean code guidelines that can be applied to UI code as well, and others are UI dedicated guidelines. The examples I will show are implemented in Angular. However, the guidelines are relevant to any component-based UI framework. The first guideline is single responsibility principle. Each UI component should do one thing and do it well. The advantages of single responsibility principle is by the fact that components become smaller and therefore easier to maintain. It is also easier to reuse components that are small and have one specific responsibility. Those are indications when the single responsibility principle is not kept and the component is doing too many things. The first indication is that there are too many inputs and flags, and the other indication is that the tests are very long. Second guideline, composition. The idea behind composition is that in order to achieve functionality, you should combine multiple components. The code is broken into several composable components, and the parent component is responsible for orchestrating the components and sharing information between them. The advantages of composition is that it's easier to test functionality when you test each and every aspect of it separately, and also it allows to replace single part of a functionality easily if it is encapsulated on its own component. Reusability. Aim to reduce repeated code. Introduce shared components for common functionality and use it across the system. You gain components that have the same look and feel everywhere they are used, and also the common functionality is tested only once. Single level of abstraction. The clean code guideline says that all statements of a method should belong to the same level of abstraction. If you take this guideline into UI code, it means that a single component should not mix custom components, HTML elements, and basic components. Let's take a look at a code example and see how we can apply those guidelines into the component hierarchy of the episode result component. So this is the code of the episode result page if everything is in a single component. It's hard to read in a presentation, and also it's hard to read and maintain in real life. So let's see how we can improve it by applying the guidelines that we've discussed earlier. The highlighted code is focused on presenting and updating the results in a single obstacle. We should apply the single responsibility principle and encapsulate into its own dedicated component. So this will be the obstacle result component. Looking into the page code right now, it's better, but we can improve it more. You can see highlighted the logic for rendering the candidate selection control. However, we can see here that there is a mix between basic components and custom components. That's an indication we should introduce another layer of abstraction. So, as you can see here, we have a dedicated component for the candidate selection and also a dedicated component for presenting results in a specific obstacle. This parent component also demonstrates composition. The entire functionality is composed by multiple components, and also the parent is responsible for updating the obstacle result whenever the candidate selection changes. We can apply reusability inside the obstacle result component. The start time and end time are actually the same functionality. They both require an input of minutes and seconds. So I've introduced a dedicated component, which is the duration picker. It is used twice. However, the logic for validating the inputs format is in a single shared place. The last guideline is presentation versus container. This is the life cycle of an average web page. First, the page load the data, then the page present the data, get user input, and store the updated data. Let's drill down into loading the data. You first need to get the identifier from the router, then invoke several API requests to get the data. You need to wait for the result and maybe later invoke additional cascading API requests, and eventually need to handle failures. Saving the data can also get complex. Sometimes there is a logic to decide whether it will be a create API request or update API request, and of course need to handle failures. When the logic for loading the data and storing the data is complex, the recommendation is to split between container component and presentation component. The container component, which is also referred to as a smart component, is responsible for interacting with the bigger application, for loading and storing data, interacting with the router, and state management. It's basically phase 1 and 4 in the page lifecycle. The presentation component, which is also referred to as the DAM component, is responsible for presenting the data to the user and receiving user updates, which is the phase 2 and 3 in the page lifecycle. In this example, you can see a presentation component for the episode result page, and you can see that all the data is received as inputs. Later on, this component will emit events to the parent whenever the data changes. So, presentation and container shouldn't be applied to every component. It is useful, as I said earlier, when the data for loading and saving the information is complex, and also when the same presentation is reused with different data sources. For example, a table component will usually be a presentation-only component, since it allows presenting various data sources in a table structure. To summarize, these are the guidelines and best practices that I find useful: single responsibility principle, composition, reusability, single level of abstraction, and presentation versus container. I would also say that applying guidelines is an iterative process. Usually, when a component is being created, it is according to all the guidelines, state of the art. However, it is being extended little by little, and sometimes it's possible that you didn't notice and the component is no longer keeping the single responsibility or single level of abstraction principles. So it is important to know that and make sure to refactor your component from time to time to make sure it is indeed easy to maintain and easy to reuse. If you have any additional questions, you are welcome to contact me on LinkedIn. Also, if you have any additional best practices that are important when designing the component hierarchy of a web application, I would love to learn about them, so write to me as well on LinkedIn. Thank you very much for listening.
Hey, I'm Talbetchuk and I'm a software engineer at Wix. I want to start by telling you a story. A few months ago, my product manager came to me and said, "Hey, we want to build a new page that includes some components. Most of the components already exist in the company and were written by other groups, so it should be really quickly, just copy-paste them." Wow, just copy-paste them. It can't really happen to me. That's not good, but let's do it in the best way and start from the first component. The goal, as I got it from my designer, includes two different cases. In the reality, there were much more than that. They have few things in common, like title and subtitle. The input must include many validation, the texts are different, and the styling is different as well. This unit will probably be shown in many places in the company product. I started to look at the code of one of those components, and that's what I found. The existing component is a part of a modal that includes also another component. The data of both components is saved by the same save button. The Redux story includes a lot of things. When I wanted to understand what is done during the save, I saw that I have a weird function that is implemented in different repositories. Okay, the current code was long, messy, coupled to the current project specifications, and mainly can't be moved
surely not as is to my new page. It won't be quick, first, or easy. I wish I could just copy-paste it. So, what could be a solution? As I said before, this component can be used in many places in the company code. We want it to be as easy as copy-paste to use it, with the respect of giving developers the option to modify it at a few points. It's called platform. What is a software platform? In my words, we all use platforms, either when using Create React App, using APIs of an external library, or implementing COM extension. Not only that, if we develop as a part of a bigger company, we use platform when programming on top of our company platforms. So hey again, I'm Tal Bebchuk, and in my current position, I'm an engineer in a platform team. My goal is to give the developers the programming on top of my platform to concentrate only on their logic and needs and not on the common things that without my team would be done by each team separately. Every piece of software begins with a single line of code and grows from there. When the codebase becomes big, there are more things that are done multiple times. To be efficient, there's a need to build common abstractions, interface with internal platforms, and handle common issues. Why is it good? Okay, so first of all, it enables fast delivery of products because less development and testing is required. It enforces standards for projects within the company, and it improves the quality of reused code parts. It reduces development and maintenance cost. Prevent risks by reusing the previously proved solution. You will not recreate bugs over and over again when you implement another duplication. It gives us a better project estimation for time and cost because we know some parts that already exist and can be used, so we won't need to implement them again. And mainly, it prevents teams from reinventing the wheel over and over again by solving common problems. We want to let the developers do their job and not the common job. Let's get back to our example. I want you to change your mindset and think as a platform. I know it sounds hard and reserved only for big companies and their infrastructure teams, but actually, I believe that each and every one of us can do it in our daily work. When thinking as a platform, we want to break it down into small parts so every part can behave as a platform. So again, we need to create a component that has a title, a subtitle. In case A, we want to show a button with text and an input with given values. In case B, we want to show all as text and add a link button. For the input, there are many validations that should be done. When the input changes, we want something to happen. We want to think as a platform, so we need to think of our next users. What will they want? If someone, now that's us, will want to use this component in the future, what will they want to be done on our side? What will they want the control on? We want to look for the places of double duty and reduce them. Not only that, what if we don't support what they want? How easy would it be to extend the component in the future without introducing breaking changes? In my opinion, and in our specific case, they will need to give us conditions to show each part of the component and its UI, and they will be happy that we, as the platform owners, will manage the validations for them. They should be the same validations for all the places that has this input in our company. On the other end, they will probably want to control the on-chain callback because our future users probably want to save the data in their own databases or to do something else with it. Let's go quickly to the implementation. Our API for the platform, in that case a component, will have a title, a subtitle, a condition for showing a case, a text for currency and for the current input, and then a callback for don't change. In our implementation, we will render the title and the subtitle, and by the condition is A, we'll decide which sum component will show. For case A, we'll render the given text and an input with a given value. When it's changed, we want the common validation to be invoked and then to give the users the control of what to do with the new data. For case B, we'll render the given text and render a button with a link to a common URL. What will we get? Our users means every developer that will need to use our component will just need to import our component and pass the relevant and specific fields, while we will manage all the shared logic and UI in one place. Yes, it's that easy. I think that every engineer should always think if he has an opportunity to create something reusable. Okay, that's amazing, I convinced you, but what are the challenges when building the platform? First of all, deprecations become really hard. We need to think of all of the users that use our platform because we are gonna break them. The process requires ask them to change the code, assign a deadline, or change it by yourself in their code. And probably it won't work as expected. Do you know the feeling of a new version of React which deprecates a useful lifecycle? And how annoying is it to change it? So that feeling. And from the other side, the component side, let's think about our platform component. What if we need to remove something from there? We'll need to ask all the users to remove them or to put an ugly default on our side. As a direct result, API worth thinking. We have users. How does this technical decision affect our developers? How can we make this change easier for them and for other teams to adopt? So in that case, I'm the owner of Alice, my dog. But in the platform case, who is the owner? What happens if someone needs a specific thing on top of the platform? Who implements it? Where's the platform code at all? And in the platform component, what if someone needs a specific tooltip on top of the component? Maybe another theme. Who's gonna do the work? As a platform owner, you need to convince others to use the platform and trust you. It requires design for testability so the users will be sure that they integrate it correctly. But is it always a good idea? Well, let's think about a simple server that has a few endpoints and integrates some calls to data. If we think as a platform, we might take this simple server and implement it as a long file that imports from many places and exports all, so the users won't be dependent on any specific thing or structure. We'll do it so open to changes so we don't even ask the user to use REST API. Instead of a simple implementation, we have a difficult code base that it's hard to maintain, takes much longer time to develop, and requires over-engineering. To summarize, we all use platforms. It exists in our daily work. So in the next time you create or refactor something, think if it works to build it as a platform. Look for the opportunities to create reusable things, do it in the best way, and invest the effort of doing so. Thank you.
Hey, I'm happy to be here. Today we will have a lecture on cracking the code review. So I'm Stella, I'm a software team leader at Checkpoint, and I have 10 years of experience developing from users' point of view. And creation out of nothing is my real love. And as you can see, running is my second love. So let me start by telling you about an experience I had that verified my initial thoughts about how code reviews should be conducted. It started with a phone security bug, and one of my colleagues was working on a fix. I guess you all know how urgent it is to provide a security patch. It should be as soon as possible. So we had reached the code review stage, and the ETA was breathing down our necks. So to speed up the code review process and not neglect the quality, we concluded the two team members will review the code. At this point, my colleague and I started to review the security patch separately. I would like to ask you to think, what would you do as a reviewer at this point? So the most common way to review code, no matter the tool you are using, is to have a diff between the code to be committed and the base version. Some teams prefer to review every change merged into the main branch and go over the files one by one, while others will have a triviality threshold under which a review is not required. A strict code review, going file by file, is perceived as the safe and the correct way to review, as you are going through every single change, but that's not absolutely true. If I have to review this diff strictly, I will start by going to the kitchen and grabbing a cup of coffee. So by reviewing code strictly, you do go over all the diff, but it can lead you to feel overwhelmed and not to follow the code flow and miss critical pitfalls, bugs, and design problems that can cause to low standard code. And we all know what low code standard can lead to. The code can be hard to be maintained. It can lead to spaghetti code and other evils, you know. So, do you know this feeling? You can't see the forest for the trees. Today we we will try to avoid this feeling when we approach our next code review. So I would like to offer you another approach to review code. I call it the top-down methodology. What does it mean to review code top-down? The top-down methodology means that review should start from the highest level of the bug or the feature you are reviewing. So what is the highest level? As a reviewer, when we approach a review starting at the highest level, we must start with ourselves and prepare for the review. When you know what you are going to review and have not yet seen the solution, at this point you can think of your own solution objectively. With your own solution in mind, you have a better perspective and a comparison point while reviewing. This is how I started to review the security patch. I had my own solution in my mind. So the next step at the top-down review is the test. I call it TDD from code review perspective. As in medicine, we don't skip on tests. We cannot skip on them at the code review, whether they are code written tests or unit tests made manually by the author. By starting from the test, you will actually understand exactly what you are reviewing As you are seeing the usage of the new code or the bug fix, you will be able to check if the feature was tested properly, including edge cases, and compare it to the solution you would do. If the tests were not appropriately made, there is no point in continuing with the review till test completion. Skipping on reviewing the test has huge cost in case of bug discovery in production, much more than reviewing them at this stage. The security fix I review, I started the review with the unit test checking that the patch indeed fixed the bug, which was found to be true. But I discovered that other flows that worked properly before the fix were not working well, what we call degradation. This was super productive for all of us, the author, me, and the other reviewer, as it was a quick iteration, and the fix author continued to work on the patch. So without wasting time reviewing the code itself, we gain a quick iteration and keep on high product quality. The next to be reviewed are documentation and UI or UX. Yes, documentation must be reviewed. Actually, I'm not sure if it should be after or before the test review, and it doesn't really matter. What matters is that it will be earlier at the review. By reviewing documentation initially, you will have the chance to read the documentation from the user's perspective and without your thoughts being dirty with the written solution. And about the UI and UX, if there exists, check that all fit to the feature requirements. There is no point in reviewing the code before making sure that the user interface is made as designed. Next to continue with is the code link points. Yes, we're at the coding stage, and yet hold the horses. We start with the link points in the code. So what are the link points? Code link points are old code parts that have changed and use the new code. Based on the linking points, you can review first that the logic of the old flows was not changed without need. And second, and more important, you can review the new code usages and to check and to review the new code objectively without seeing the new logic, only the usages. And to ask yourself, does it serve the purpose? Are APIs well defined and intuitive to use? Are best practices implemented? A simple technique to start with the code link points is to start with the existing files, not with the new files to be committed. In this way, you follow the code flow. And actually, we all do this while coding. So why not do it when we're reviewing code? And of course, you'd better be familiar with the code and the flow you are going to review, as you don't want to be a rubber stamp. You got the idea. There is no point to continue with the review if there are a bunch of comments at this stage. When I reviewed the code link points at the security fix, I found APIs that were not defined properly in terms of encapsulation and more comments on redundant dependencies that I found. After reviewing the link points at this iteration, my other colleague was still reviewing the code. And as I found lots of comments, I didn't find it reasonable to continue with the review. So we set a meeting, me, the author, and the other reviewer, to go through my comments. And while we are doing it, we agreed on required changes in the interfaces that will cause the new code implementation changes. And remember, at this stage, I didn't review the new code yet. The other reviewer took a different approach to review. He started with a new code that contained new classes, functions, and new logic. In our meeting, we found out that his review is not relevant at all, as following my comments, the implementation is going to be changed. So this was really mind-blowing. This was really mind-blowing for all of us. As with different approaches to review code, we shortened the review iteration and we gained an advantage with the ETA. So it was proof for us that with going top-down, we gain productivity. We can discover problem at an early stage in the review, and we create a quick iteration of review and fixes. Second, we scale up code standards. And last, we improved stability as we made sure that the feature is well tested. So after all of the others have been reviewed, it is the time to review the new code to be committed. From here, you know the job. Do you see a potential for useful abstraction or code reuse when possible? No redundant dependencies. So I know it may sound overkill and hassle, but if you think about it, you either way are going over all the diff. Then why not do it? Why not do it effectively? So let's sum it with 5 steps. First is you. Come prepared for the review. Know what it is about. Think about your own solution in advance. Second are the tests. Go over the test. Does the new code serve its purpose? Were edge cases tested? And after it, go to the documentation and UI and UX. Take the opportunity to see things from the user's point of view. It is your time to review the fix in an objective way. After it is the time to review the existing flow that use the new code and kill 2 birds with 1 stone. You are making sure the current flow logic is correct and the usages of the new code are making sense. And last is the new code. Now you are ready to get the job done. So when you approach your next code review, keep the top-down methodology in your mind. Even if you will adopt only one thing to start with, reviewing the test first or coming prepared, etc., you will gain all the benefits. The more you will adopt, the more you will gain the benefits. And clean code leaves me time for a happy hour. And we all agree about that. There is nothing better than that. So, thank you for joining me.
Hi, everyone. I want to start by saying thank you all for coming. My name is Dal Katsovich, and I'm a product manager and software engineer. I've been in development for the most of my life, and I'm passionate about building and creating products. In the little time I have today, I want to share with you a few of the things that made me a better developer, which I actually learned from my role as a product manager. I started to develop when I was 10, writing my first lines of code in HTML. I obviously loved it since I decided to learn computer science during high school and then kept developing for more than 10 years. Over the years, I worked with almost any kind of coding language that you can think of, and I had the privilege to touch all aspects of the engineering stack: front-end, back-end, Android, iOS, and even a little bit of DevOps. So essentially, most of my career and most of my life really, I've been working with code. A little over a year ago, I started working as a product manager at CyberReason, a cybersecurity company that I'm sure that many of you know. As I see it, engineers have a huge part in the success of the product. They are the inventors, designers, and creators. They get a set of requirements and restrictions like cost, security, and skill, and need to build the best solution that should fit another set of existing limitations, like performance and backward compatibility. As a software engineer, every time I got a new task, I find myself immediately starting to think about the solution, jumping straight to what should be the architecture, where is the problem in that bug, and when can I start to implement. I wanted to finish all my tasks as soon as I could, and I was running to how the feature should work on the system level rather than the product level. I always thought about creating the best code and best feature. But the truth is that writing great code doesn't always mean creating a great product. Working as a product manager kind of changed the way I look at engineering. As a product manager, naturally, I need to look at products from a different point of view. You see, in reality, our users don't care about the code. What they want is to have a solution to their problem. So I must focus on the value provided to them. This made me realize that what I used to think is the best way to go as a software engineer isn't necessarily true now when I understand the full picture. Today, I would like to share some of these insights and thoughts. Basically, I found that the typical set of questions often used by product managers are super relevant for engineers to ask themselves before starting to design and develop. These questions work with any feature, bug, or functionality. And I find that asking them not only helps me develop better products, it also makes me a better engineer. So, ready? The first question I always start with is, who is it for and what is the need? First of all, we should identify our users. Knowing who our users are and understanding what they need is important so we can make better engineering decisions. Here's an example. Let's think of a candy store owner, and to make it easier, let's call him James. James has a candy machine in his store, and he wants to know how many purchases are made every week. So as engineers, typically we would develop a report of all weekly purchases for James. Let's say James gave us the database of his store, and now we can write an incredible piece of code that would generate that weekly report. But before we jump right to it, we should take a moment to really understand James. Who is he? Why does he really need such a report? Well, he's a candy store owner, and he wants to make sure he always has all types of candies in his store so we can provide all his customers' desires. This report should help him know what's in stock and what's need to be ordered. If we think of it now, a purchase report probably won't really solve James's problem. He will most likely will ask for another report for the missing candies so he can order more of them. This means that when designing, we probably need to build an infrastructure for multiple reports instead of creating just one. And if he needs to get a report once a day by email, it's really okay if it takes 10 minutes to generate it, because he doesn't stand and wait for it, right? But if we need to generate a report for his candy supplier at the moment that he enters the store, he probably wants to get it in 2 seconds. It's again a question of his need. In other words, thinking about the user and understanding what they want enables us to make better architecture decisions. Moving on to the next question. What does success look like? Or in other words, what is the goal? Success means different things to different people. As a developer, I used to think of success as a code with 0 bugs that is easy to maintain and sometimes even as the number of lines of code I've deleted. I'm not saying it's not important, but it's not the only thing that matters. Because in reality, this perfect code I wrote might have 0 value to the user and product. Thinking about what success looks like for the business and how we can make an impact could make a difference. Success could be the company goal, like user acquisition or generating more sales, and it could be the goal for a specific feature or use case, like the expected user experience, the crucial of performance, or the importance of running in real time. Each answer generates a different design, and this can affect the solution as a whole. Let's see an example. Here's James again. Let's try to think about his goal. As a store owner, he probably measured the number of customers and purchases every month. So what does success look like? A lot of people that walk in and buy a lot of candies. And to understand how it will help us to make decisions, let's assume James has a new candy machine in his store that generates new candies every time a customer presses a button. Now let's say we try to improve the candy creation mechanism of the machine. We change the algorithm and it now generates 4 candies instead of 3 every time. But we also increase the time it takes to get the candies by 300 milliseconds. Should we keep this change or revert it? So it's an easy one if we are considering the big picture and James' overall goal. Let's ask, after this change, are we generating more sales? Do we have more people that buy more candies? If the answer is yes, we made a good impact and we improved our business performance. Keeping the goal in mind while developing immediately move the conversation to what matters the most and enables the right decision for the product. Moving on to the next question. What is the minimum value I can deliver? I'm sure you all heard about the product concept of MVP, minimum viable product. And as you already understand, I think it's relevant for engineers as well. The idea of the MVP is to introduce to our user the smallest piece of functionality as quickly as possible to get feedback and learn if it's valuable, and if not, change accordingly. As engineers, we should also care about developing in small chunks, so we could focus on one thing at a time and also to test our assumptions that we made while designing, like it will work at scale. And also our business hypothesis, so we won't waste time on something that won't fit the user, like improving a query to load a page that is barely used. For this example, let's say James wants to create a new candy machine. While designing, we should think of the best way a user can get a candy using the new machine, the most effective, straightforward, and intuitive way. And then, to back to our assumptions and ask, is it technically doable? What do we need in order to make it work? Do we have the time, the resources? And if not, what would be the smallest piece of code and functionality that will give value? and that will help us to learn what do we need next. We want our code to be flexible, manageable, and easy to develop and maintain, but also relevant and valuable. And don't forget, time to deliver is also a parameter. A good delivery or feature is measured by value divided by time. If developing the best feature ever will take 3 months, it might not help some businesses, because one of their competitors can easily develop something smaller and steal all their customer base. So it's always a matter of both time and value. Understanding that will help estimate how complex or difficult something will be and decide whatever feature will be worth the development effort. Delivering in small pieces creates a great environment to learn about what is needed, product and engineering-wise. Last but not least, what else? This question is my favorite one. I personally use it all the time, and I find it helpful not only at work. I really think it's the most important question one can ask. This is the time to think outside the box and ask, what else? What else I should know, or what else can I do to improve? It's an opportunity for the product manager to mention anything that's important to them. And as engineers, we might benefit by getting more context of what we're doing or hearing about a quick win we can implement easily. What else I should think of? Maybe we already coded something similar once and some of the functionality exists. What else? Did we cover all use cases? What happens if we have more? Can we add them easily? Many edge cases are technical and won't be endorsed by the product manager. It could be broken APIs or insufficient memory. This is totally the time to collect all the missing information. And what else? Just ask. If you know how to answer all these questions that we've covered, I bet that you'll have more follow-up questions as well. So ask. Don't be shy. And the product managers might not mention something because for them it might be obvious, or they might not have all the answers. And maybe you'll have to think together and investigate. But if you ask the right question, you also might discover a better simple solution, something that wouldn't have come up otherwise. To conclude, programming for me is more than just typing code. It's the art of solving complex problems, building something from scratch, and think about all aspects. Asking this question is a proven way to get a clearer, broader picture of the problem and solution you're working on. And so it would be easier to come up with everything you need to build the best solution and become a better engineer overall. Thank you.
We finished our second day. Our conference is finally over, and we couldn't be more thrilled you were here with us. Thanks again to all of our amazing sponsors. We truly couldn't have done this without you. Your companies are true allies, helping us to support diversity and being part of the change where women will make 50% of tech speakers worldwide. Thanks to all of the people who were involved in making it happen, helping us to make our dream come true. To the speakers and keynote speakers at the conference, you are truly amazing. We're counting on you to be the next thought leaders of the entire tech industry. Thanks to Event Handler for producing the conference, to Microsoft and Baot Community for turning the Academy course from a dream to reality, and obviously to all of our course mentors and world-class instructors. Be sure to follow us on social media, invite our speakers to speak at your next event, register as a speaker on our platform yourself, or register to the next round of the Speakers Academy. My name is Moran Weber. On behalf of me and Women on Stage, we thank you for being here with us, and we hope to see you soon at our next conference. Goodbye.